Hi, this is Aaron, Boys Program Coordinator at the West Grove Garage. Today we're going to talk about bread, but not how to cook it. Rather, I want to talk about why bread is so important and how making something so simple requires really complex science to understand it. All bread, though, is made with two main ingredients, flour and water. And then bread's divided into two categories, leavened and unleavened, which we'll talk about in a minute, and then most bread has salt in it for flavor. The difference of how you get, say, a flatbread like naan versus a nice fluffy sandwich bread, it's all based on science. And the three biggest scientific processes are hydration, protein manipulation, and fermentation. So first, let's talk about hydration. Hydration is the balance of water and flour. Some bread is high hydration, meaning there's a lot of water, while others are low hydration, meaning less water. So to understand this, bakers use what's called a baker's percentage, as shown in this diagram. So for an example, let's take a typical recipe of 1,000 grams of flour. So a high hydration of 75% would be 1,000 grams of flour, 750 grams of water. A bread that has a high hydration will be light and fluffy, whereas a bread with a low hydration will be denser and heavier. So once the flour is made a dough and it's hydrated, the next process is called kneading. And what kneading is, it's protein manipulation. In flour, there's two proteins, glutenin and gliadin, which do not mix until we start kneading. Kneading aligns these proteins into a stretchy web called gluten. Gluten is important because it makes the dough elastic and stretchy, which is important for the fermentation, which we're going to talk about here in a few seconds. Developing gluten in a dough will make the dough lighter and chewier. If you don't knead it enough, the dough will be dry and crumbly. You can see here as I'm kneading it, it starts off kind of shaggy and jagged and really, really sticky. And the more and more I knead, when I'm finally done, it's smooth. It has a smooth roundness to it. That's because the gluten has aligned and everything is more elastic. Now, fermentation is probably the most important component to bread making from a scientific point of view. There are two ways to incorporate yeast into your dough. One is using market yeast like I'm doing here. The other way is to leave your dough out for a few days so it can collect the natural yeast from the air. So this part is called the rise. And the way the rise works is the yeast in the bread eats the sugars, the carbohydrates that are in the wheat, chews them up, and basically burps out carbon dioxide gas. Now, earlier I talked about how important gluten is, and this is why. A high gluten bread, that dough is going to act like a bubble. That gas is going to come out, and the gluten is going to hold a bubble of air in the dough. If there's no gluten, the air either gets trapped and nothing happens to it, or it'll just kind of squeeze out. And those air bubbles are what cause the bread to rise and get nice and fluffy. And that's why baking bread is so interesting, is because depending on the science and the ingredients you use and the techniques you use, you can get very different products. You can use stuff like butter, eggs, sugar, seeds, herbs, yogurt, honey, cheese. You can add anything to a dough and you're going to get something delicious out of it. So I hope you can learn to appreciate the hard work that real bakers do, not bread that comes from like a factory, but people who actually make the bread with their hands. We like bread that's cheap, but it requires a lot of work to make really good bread. And the funny thing is that all you need to make bread is water, flour, salt, yeast, and an oven. It's so simple. You can see all I used was a bowl, those ingredients, and an oven. But from these building blocks, all we need to use are different techniques and some science to manipulate those four ingredients into hundreds of different recipes across the world.